So, in this video, we'll try to work out the perpendicular bisector of a line segment. We are given, in this particular example, 2 points, 3,2 and 4,5. They are going to form our line segment. And once we know the line segment, we want a perpendicular bisector to that. Now, a bisector is something that divides a given geometrical construct. And in this example, if we have a line segment like so, then a bisector could be any line emerging from the center, like so, not like that. Well, if you assume that this cross here is the center, then the bisector could be any line that emerges from the center of the given line segment. Now, a perpendicular bisector is a special case of all bisectors, which happen to be at 90 degrees from the given line. And so that's a special case of a bisector, and that's what we call a perpendicular bisector. Now the key point here is to note that the perpendicular bisector is actually perpendicular to the line segment. And that means that we must employ our knowledge about perpendicular lines in terms of their slopes. And what I mean by that, if two lines are perpendicular, then the slopes of them, then their slopes eventually multiply to give you a constant of -1. And we must use this property somehow, somewhere throughout this problem. Anyway, to begin this entire example, it's always better to plot the points, and I've done that slightly before. So the first point, say point 3,2 would be at 3 unit distance from the y-axis along the x-axis, and 2 units in the y direction above the x-axis. So that gives me this point here. I should call this point 1. And the coordinates are 3,2 as written there. Similarly, for if I want to plot the point P2, it's going to be there, which is at 4 units in the x and -5 units in the y. That gives me this point right there. Now, a perpendicular bisector would be a line that bisects this line segment. But let us draw the line segment to begin with. So if I change my pen color, say I'll put a red, so this line segment right there is going to be the given line segment. And if we want to draw the perpendicular bisector, then we must be perpendicular to this line segment, somewhere there, and we must be right in the center. So if we assume that this is approximate center, then the line we're looking for as our perpendicular bisector is this green line, right? All right, so the properties of this line is the fact that this angle here is 90 degrees, and this point at which the perpendicular bisector, I shall call this perpendicular bisector, the point at which the perpendicular bisector intersects the line segment, well, this is the midpoint of the line segment. Therefore, with all this, we can now proceed to figure out the equation of the perpendicular bisector. All right, so the first thing is to find the midpoint of the line segment. The midpoint would be, as we already know, if these are the two endpoints of the line segment, then the midpoint has to be, well, of the form of x1 plus x2 by 2, comma y1 plus y2 by 2. And using that, we can write our perpendicular bisector, our midpoint, as, well, x1 is 3, x2 is 4. So this gives us 7 by 2. And y1 is 2, y2 is -5. When we add 2 minus 5, that gives us -3. And we must have a 2 in the denominator. So this is the midpoint through which a line passes. That's half of the problem done. Now, we must go on to figure out what is the slope of the bisector. Right, so if I call the slope of this bisector to be m sub b, and I call the slope of the line segment to be, well, m sub l, then I know that because these two lines are perpendicular to each other, ml times mb must be -1. That's the property of perpendicular lines. And I can write this, I can basically substitute the value of m sub l, because we know the points through which the line segment passes, and that's 3,2 and 4,-5. So the slope becomes the difference in the y-coordinates. Let me write that as 2 minus -5. The y component here, the minus y component there, and we divide the whole thing by the difference in the x components in that order. So that's 3 minus 4 multiplied by m sub b, well, that should be -1. We can simplify this a bit more to get, well, 2 minus -5 is 7, and 3 minus 4 is -1. That gives us mb, and we should multiply both of them to get -1. So we can solve for mb, and mb turns out to be, well, we can divide the entire equation by 7 to get mb equals 1 by 7, right there. So the slope of the bisector needs to be 1 by 7, and the line through which the point through which it passes should be 7 by 2, comma 3 minus 3 by 2. Now we have our description of the line. We know that the line passes through a given point, and we know it holds a certain slope. Therefore, the only thing to do at this point is to write the equation of the line from the formula that we know as y minus y1 equals the slope of the line x minus x1. If you remember what the points y1 and x1 with respect to this line here, well, the points that they represent are 7 by 2 and minus 3 by 2. We can simply substitute the values of m, y sub 1 and x sub 1 to get y minus y1 is minus 3 by 2. That's equal to the slope, which is 1 by 7 from here, times, well, x minus x1. So that's x minus 7 by 2, right? So this is my equation of the bisector, the perpendicular bisector. So removing all of that, we have my equation of the bisector. Well, perpendicular bisector, so let me write that as p dot b dot right there. We can solve this eventually, and if you want to solve that, well, you must just add them up like so. So that's y minus 3 by 2 is y plus 3 by 2, well, equals x by 7, and 1 by 7 times 7 by 2 is minus 1 by 2. At this point, we can make y the subject of the equation to get y equals x by 7 minus 1 by 2, well, minus 3 by 2. If you add these two fractions up, you get y equals x by 7 minus, well, 3 plus 1 is 4. 4 divided by 2 is 2. This is the equation of the line. Therefore, our equation of the line finally becomes, well, in the form of y equals mx per c as x by 7 minus 2. If you notice, we are not very far from what we got theoretically. If you look at the bisector line, the green one here, then from this equation, we know that the y-intercept must be, well, -2. That means if the line is extended all the way to the y-axis, it must cut at a distance of around -2. If you count the number of steps here, the number of unit steps, well, that's 1 and 2. So it's very close, in fact. So the -2 component is satisfied. And if you look at the slope of this equation, well, the slope, as we found out previously as well, is 1 by 7. And if the slope is greater than 0, or if it's basically positive, like it is in this case, 1 by 7 is a positive number, then the line must be sloping upwards. That is, that if you walk towards in a greater x direction, in such a direction that points along the x-axis, then it would feel as though you're climbing up a slope. That is to say, in other terms, that the angle that the line forms with the positive x-axis is a positive angle. And that is also verified. That is also what we see through our diagrammatic representation. So we're not very far from what we actually wanted to draw. In fact, we got a very good diagram to represent the exact description of the perpendicular bisector to the line segment, which is formed by 3 by 2, 3,2, and 4,-5. So right there, we have our bisector. Hope this video helps, and all the best.